Hello everyone. Here we are going to discuss about the topic theory of electronic transition, which belongs to unit 5 spectroscopic technique. We know that the molecule exists in discrete energy levels. What are these discrete energy levels? The translational energy level, rotational energy level, vibrational energy level, and electronic transition energy level. Now, when electromagnetic radiation falls on the molecule or they get absorbed by the molecule, then depending on which electromagnetic radiation is absorbed by that molecule, different kind of energy levels can be excited. That means the discrete energy levels can be excited to the excited state energy levels. When UV visible light falls on a molecule, then this UV visible light is having ability to excite the electrons from ground state energy level to the excited state energy level. That means UV visible radiation is having ability to carry out the transition of electron from ground state energy level to the excited state energy level. Now, before going to the theory of electronic transition, we'll just have a look about the different types of electrons present in a molecule. We know that the organic molecule are formed by the sharing of electrons. Now, due to the sharing of electrons, there are two types of bonds in a organic molecule. One will be called as a sigma bond, another will be called as a pi bond. Now, whenever the electrons that are involved in the formation of sigma bond, then such kind of electrons will be called as a sigma electrons. While the electrons which are involved in the formation of pi bonds, that electrons are called as a pi electron. That means whatever the electrons that are responsible for the formation of double bond or triple bond, they will be called as a pi electrons. While in organic molecules which consisting of heteroatoms, that means the atom other than the carbon, okay, the molecule which consists of heteroatoms, in such molecules the electrons are present in the paired form. They are also called as a paired electrons, or they are also called as a lone pair of electrons. And such kind of electron, if it exists in a molecule, they are called as a n electron or non-bonding electron. The heteroatoms like oxygen, nitrogen, halogen, sulfur, they exhibit n electrons. Further, these electrons are having discrete energy levels. Okay. Now, the energy level in which this electron exists will be called as a lower energy level. The energy level in which this electron exists, they will be called as a lower energy level. While there are certain energy levels when which will exist after irradiation of the molecule by UV visible light. Now, what happens when we irradiate the molecule with UV visible light? Then the electrons from lower energy level will get excited to the higher energy level. That means the electrons from sigma bonding orbital or pi bonding orbital or non-bonding orbital, which is a lower energy orbital, will get excited to the higher energy level, and this higher energy level are denoted by the anti-bonding orbital. Okay. This phenomenon will be called as a theory of electronic transition. Okay. I will again repeat this. When molecules are irradiated with UV visible light, this UV visible light will get absorbed by that molecule. Then the electrons from the ground energy level or low energy level will get excited to the higher energy level, and this excitation of electron from lower energy level to the higher energy level will be called as a theory of electronic transition. In case of a molecule, if it existing or if it consists of a sigma bond or pi bond, then the electrons belonging to the sigma bond, electrons which belongs to the pi bond, that electrons will be called as a lower energy level electrons. While if it consisting of a heteroatom, then this lone pair of electron in present which are present in the heteroatom will be called as a lower energy electrons. Now the antibonding molecular orbital which exist in a molecule just like sigma star and pi star will be higher energy level, and the electrons will get excited from sigma, pi or n orbital to the higher energy level sigma star or pi star orbital. Now this diagram will explain how the excitation will explain. If you check this diagram, this is the energy level diagram in which there are several discrete energy levels. Now the sigma bonding energy level will be the most stable one. Then above that there is the pi bonding energy level, non-bonding energy level. So all these energy level, that means bonding sigma, bonding pi, non-bonding n, will be called as a lower energy level, while anti-bonding pi star and anti-bonding sigma star will be called as a higher energy level. Now when UV visible light falls on the molecule, then there is excitation of electrons from ground state energy level to the excited state energy level. Here possible excitations are sigma to sigma star, pi to pi star, n to sigma star, n to pi star, while excitation of electrons from sigma bonding orbital to the pi antibonding orbital or pi bonding orbital to the sigma antibonding orbital is prohibited. They are not possible. Now we will see one by one the different kinds of electronic transition occurring and what are the examples. Now we will take first sigma to sigma star electronic transition. When the electrons get excited from sigma bonding orbital to the sigma star antibonding orbital. When electrons get excited from sigma bonding orbital to the sigma star antibonding orbital, then the excitation will be called as a sigma to sigma star transition, or the transition will be called as a sigma to sigma star transition. As we know that sigma bond is one of the strongest bond, it is one of the stable bond. Hence, the electrons which are involved in the sigma bond are stabilized, while sigma star is having very high energy, and hence the energy gap between the sigma and sigma star will be highest among the different transitions, and hence the radiation which belongs to near UV, or we can say the radiation which belongs to 120 nanometer 200 nanometers will provide the energy which will carry out the sigma to sigma star transition. Example, the molecule which consisting of sigma bond will carry out the sigma to sigma star transition. So saturated hydrocarbons like ethane, cyclohexane, such kind of molecules will show sigma to sigma star transition. Further, the n to pi star transition. Now again, the excitation of electron from non-bonding molecular orbital to the anti-bonding pi orbital will be called as a n to pi star transition. Excitation of electron from non-bonding molecular orbital to the anti-bonding pi orbital will be called as a n to pi star transition. This transition is also called as a R band. or we can say that the the graph or the peak obtained by this transition or due to this transition will be called as a R band. The energy gap between non-bonding orbital and pi star antibonding orbital is the lowest one. Hence, very low energy is required to excite the electron from n bonding orbital to the pi antibonding orbital, and hence longer wavelength will be able to carry out such kind of transitions which requires the low energy. Now, what would be the example in this case? The compounds which consisting of heteroatoms along with the olefinic bond. Again, I will repeat, the compound which consisting of heteroatom along with the olefinic bond. Such kind of molecule will have ability to carry out the N2 pi star transition. For example, acetone, acetic acid, then aldehydes, such kind of molecules in which there is a presence of heteroatom along with the low olefinic bond, double bond or triple bond. Such kind of molecule will carry on the N2 pi star transition. Further, N2 sigma star transition. Now, excitation of electron from non-bonding molecular orbital to the anti-bonding sigma orbital will be called as a N2 sigma star transition. So again, I will repeat that the molecule which consisting of heteroatom like oxygen, like halogen, along with the sigma bond will be able to carry out the N2 sigma star transition. The example is the aliphatic compound or saturated hydrocarbons containing heteroatom like alcohol, amines, thiols. The further main transition which is giving us important information about the molecular structure will be the pi to pi star transition. Now, whenever there is excitation of electrons from pi molecular orbital to the pi star antibonding orbital, then such kind of transition will be called as a pi to pi star transition. There are three types of pi to pi star transition. First is the K band. Now, when pi to pi star transition takes place in a molecule which consisting of conjugated double bond, then such kind of transition will be called as a transition which gives us the K band. For example, is the butadiene. So, any molecule which consists of a conjugated double bond will carry out the pi to pi transition in the K band. Then further will be the B band. So, all the molecule which is benzenoid kind of molecule, aromatic molecule or heteroaromatic molecule, such kind of molecule will show B band, and as the aromatic molecule and heteroaromatic molecule shows such kind of transition, it is also called as a benzenoid band. E band. E band will be shown by the molecules which consisting of a isolated double bond. So the molecules which consisting of isolated double bond will show E band, that means pi to pi transition, which contributes the E band. So it is also called as the ethylenic band. For example, is the ethylene, then propene. Such kind of molecule will be responsible for the E band. Okay. So these are the different kinds of electronic transition that occurs in a molecule. Thank you.